I do offer a variety of courses. This is more along the 101 side of it, but I think it can be quite informative for those people who are not super familiar with the various applications of stone wool, with more of a focus on commercial building. And I'm going to try to highlight the integration with passive house building. So not all the content here is going to be specifically passive house related, but there's a lot of crossover, as you'll see. And so, yeah, just to kind of quickly add on to Andreas's notes. So I'm here as the New York City architectural manager for Rockwool. I do sit on the board for New York Passive House. So I am the kind of point person for the design and build community here in New York City when it comes to products, applications, services that can be supplied through Rockwool. And we'll talk a little bit more about that at the end of the presentation. I also serve as an ambassador for the Building Energy Exchange. I'm guessing if you're associated with New York Passive House, you're probably familiar with them too. But if not, definitely check them out. They're a great resource for the movement to low carbon building, more sustainable building in New York City. And then I'm also the chairperson for the Rainscreen Association in North America, which is a very new association. We just got going this year, but it's moving quite quickly. If you guys want more information, I definitely suggest that you reach out to the website below to get more information. But helping to develop certain codes and specific strategies with Rainscreen, particularly with a focus on high performance, low energy buildings. So a lot of good stuff going on there. Quickly, before we jump in, just an overview. So I am with a company called Rockwool. We used to be called Roxol here in North America. That changed about 2 years ago, where we aligned with our parent company name. So it's just a marketing move. Everything else is the same. But the Rockwool group has lots of different sub-companies underneath it, not just commercial insulation. We actually have a company, Rockfon, that manufactures acoustic ceiling tiles using stone wool fibers. In Europe and other parts of the world, we actually have a manufacturer of compact panels, aesthetic, design Rainscreen panels called Rock Panel. We have another group called Lapinus, which manufactures just the fibers themselves for various applications, tracks, coatings, gaskets. In fact, they're in a lot of the brake pads of the automobiles that we have here in the market today. And then we have a new division called Grodan, which is our probably most rapidly growing line of products, which is actually used for precision growing. So as opposed to using hydrophobic binders with our commercial insulation materials, they use hydrophilic binders to create growing mediums for the horticulture industry. So a lot of diversity in application and focus, but it all comes down to rock. That's in our name. That's what we are. So we are predominantly a basalt rock product. So when you look at a rock like this, you can recognize strength and endurance, non-combustibility, all of these kind of qualities are in the products that we promote and we use in the market today. So when it comes to stone wool insulation, which again, we're going to talk about once this program starts in a second, really the low hanging fruit of the benefits here is the non-combustibility aspect, right? So as we're starting to build bigger buildings, we have to be cautious of using combustible materials. And so stone wool insulation compared to some of the foams out there has a great statement around non-combustibility, no flame spread, no smoke development. But in addition to that, it's a very thermally stable product, maintaining its R value over the life of the building. We'll get into water repellency and the importance of vapor permeance, which is critical for high performance buildings like passive house buildings, particularly here in the Northeast, to be able to allow these buildings to dry. And then the acoustics qualities, right? So sound absorbency of stone wool insulation is quite good, and we'll get into why that is as we go. So just to be clear, you guys might be familiar with all the various applications that you can have for stone wool, or you might not, right? So it's not just a batt insulation that we use. We actually are able to manufacture semi-rigid and rigid products that can apply to all sorts of applications on buildings, from continuous insulation boards to curtain wall assemblies to acoustic semi-rigid boards for metal buildings or sound studios, as well as rigid boards for low slope roof, as well as under slab below grade foundation walls. So there's a lot that you can get into with stone wool, and we'll get into that here in a second. And so Rockwool has been around for quite some time. We were 1930s in Denmark. We opened up our first facility in North America in 1988. And now we have, we're just breaking ground on our 5th manufacturing facility, or I should say we have broken ground. It'll be open next year in Ransom, West Virginia. So we're the leader in stone wool insulation supply globally, and certainly here in North America. But we'll have some more kind of product discussion at the end of the presentation, but I do want to jump in here. So please, if you have questions, as Andreas mentioned, please type them into the chat box. I do have a colleague of mine, Joe Donnelly, from our roofing team, who might be able to address some of the questions as we go. But otherwise, we'll loop back and answer the questions at the end. All right, so again, this is kind of like a 101 on stone wool. We're going to talk about what is stone wool, maybe clarify the difference between what we call stone wool and what you might recognize as mineral wool, and what those differences are. And then we'll get into the attributes and the benefits of why you might want to specify stone wool versus some of the other products that are out there in the market. And we'll get into some applications, in particular, exterior wall applications and roofing applications, which I think is, for the most part, the most pertinent to commercial insulation as it pertains to passive house applications. All right, so big picture, this is more of a generic slide on the carbon emissions impact from our buildings, and with the approach of Architecture 2030 to kind of get to carbon neutrality by 2030. Certainly there's more aggressive goals like in New York City with the mayor's 80 by 50 plan, and with the new adoption of the CMA legislation. We're looking here in New York to dramatically reduce the carbon emissions coming from our buildings, because while it says here 40% of those emissions are from buildings overall, in urban environments, it's about 80 to 90%, particularly in New York City. So if we're trying to meet these aggressive goals for carbon neutrality and meet the local code requirements, there's no way we can do that without addressing our buildings. Buildings need to be the primary focus, and that's going to include not only new buildings, but also existing buildings, right? So, most of the energy's use is coming from our existing building stock. So I think retrofit is going to be a big topic here, if you're not aware of that already, that we need to be thinking about. But when we think about, optimizing air tightness and adding insulation to create kind of a passive approach and high performance building, we do need to think more than just climate change as it pertains to, reducing energy use and reducing the impact of carbon emissions. I mean, there's a lot of things going on in our environments today, from tornadoes, floods, fires, all sorts of durability challenges and issues need to be addressed through the selection of products and materials to also help meet those energy goals. And so when you look at insulation, particularly commercial insulation, you have various types that you can consider. And we'll categorize the two main typologies as fibrous insulation, which would include your standard fiberglass, stone wool and slag wool, right, in the mineral wool segment. And then you've got foam plastics, which, you could have rigid boards like XPS, EPS, polyisocyanurate, or you could look at the spray foam class, like open cell or closed cell spray foams. And so quickly looking at rigid foams as a selection for products in buildings and commercial buildings for continuous insulation. In general, these are closed cell type products. They do use blowing agents, whether or not we're looking at polyisocyanurate, expanded polystyrene, or EPS or XPS. And the blowing agents will vary, right? In polyiso, you're looking at a pentane gas. That's going to get you to about an R5.7 nominally. You have blowing agents and air inside of XPS. You have some air in the EPS products that'll get you to about an R5 and 4 respectively. So I think the key thing here is to notice that these are nominal R values. We're going to get into really the focus on effective or long-term performance R values as we go. And so when you look at stone wool, what is stone wool? And to again try to demystify things, we'll create the umbrella review here. So a mineral fiber is the generic term for any sort of fibrous inorganic substances. And so that mineral fiber can then be classified into 3 groups. And so one is fiberglass, which I think we're most familiar with. The pink low density products that you'll see quite often in between studs, wood studs, sometimes metal studs. And then you have the category of mineral wool. And so under the subcategory, or under the category of mineral wool, you have 2 subcategories, which would include both stone wool and slag wool. And so stone and slag are the 2 primary ingredients in a mineral wool product. And so really the differentiator here is if you have more stone wool, if you have more stone basalt rock, I should say, within the makeup of that product, it's then considered a stone wool. If you have more slag, then you'd be considered a slag wool. And so slag is the byproduct of iron ore when you're producing steel. And so that's really the recycled content. And it's a little bit different in terms of the makeup versus the basalt rock. And so we just want to kind of categorize and showcase the differences. So what we're going to be talking about today is more in the stone wool segment than in the slag wool segment. And then the third overarching category is refractory ceramic fibers, which are high temperature insulation materials that are often used in industrial applications for piping and things of that nature. So it's rare that you would see that as a specified product in commercial insulation. So really the fiberglass and the mineral wool products are where we kind of start our focus. So I traditionally have a video to show groups. Decided to not include that on this presentation just because it's a little lengthy and it can get chopped up in the transition to Zoom. So I might go ahead and forward that on to you guys afterwards, but it's a video from the Discovery Channel that really kind of showcases how the mineral products and stone wool products are made. But I'm just going to go over it here quickly, right? So I mentioned the combination of raw materials of basalt rock and steel slag. And you basically heat those up to the point of melting. So it does get to some high temperatures. And then as that stone slag combination starts to melt, it's spun into fibers. So it's not too different from the production of like cotton candy, but in this case, we're looking at stone. And then those fibers can be collected into either lower density bats or into higher density boards. And I think we'll get into those specifics on kind of why would we do one over the other and how those products are used. So this kind of shows the production line here at the bottom again. It's compressed into a variety of forms. And so then binders are also added for rigidity and water repellency. So it's important to note that there's a number of products that come from manufacturers of stone wool or slag wool insulation, and there's not one size fits all. So you do want to look at the individual products and make sure that those products are the right for the application, the specification. So, typically products that are going to interface water are going to be either semi-rigid or rigid. They might have specific binders to interface better there. The lower density products like bat insulations are usually meant for interior applications. So you don't want to mix those two up. But on this line here, one of the benefits certainly is that any product that falls off the line can then be thrown back into the raw material silos for production. So very little waste to landfill in the production of stone wool insulation. Basically all the material it can be recycled back into the production line. And I mentioned this already, but there's a number of different applications for stone wool in the commercial realm, right? From curtain wall assemblies, fire safety at edge of slab, trying to meet UL rated assemblies for these curtain walls, maybe which we don't see too much on Passive House, but there's certainly still a lot of it going on. We can be used for metal building, for standing seam metal roofs, for low slope roofs, and then certainly for continuous insulation on the outside of traditional Rainscreen walls, masonry walls, things of that nature. On the interior, we can also do walls and ceilings, mechanical rooms, parking garages as well. So, a lot of those are specified for acoustical or fire reasons. And so there's a lot of good data around that in both commercial and residential as well as industrial uses. All right, so why would you want to specify a stone wool insulation? So there's a number of reasons. We're going to start with fire, which we've mentioned already in terms of fire resistance. And so for those of you who don't know, stone wool insulation is fully non-combustible. There's zero flame spread and smoke development with stone wool products, whether or not we're looking at bat insulation or board insulation. And so when you start to compare this product to some of the other rigid foams or spray foams or even fiberglass, stone wool will melt eventually at 2150 degrees Fahrenheit. And so that takes about 6 hours in a full-on fire to get to that level. So it offers a tremendous amount of protection for the occupants of buildings that either need to shelter where they are or to get out of the building and giving them time to do that. It also protects the contents of buildings and things of that nature. So when you start to compare it with some of the other installations on the market, it's not a surprise why people are starting to move towards stone wool insulation for building construction. In the commercial realm, I think a lot of us are familiar with some of the high-rise catastrophes that have occurred over the last decade or two with the use of foam plastics on the outside of buildings, and that could either be rigid foams, polyiso, spray foams, or even in the panel material that you're specifying that might be combustible or have foam core materials. So This is an image from the Grenfell tragedy, which is now over 3 years old, which is kind of crazy. And with a lot of these fires, it's not specifically due to one thing, right? There was a lot of complexity on these projects, in particular the Grenfell, where there was 0 sprinklers, there was 1 fire stairwell, there was just miscommunication on exit strategy. But at the end of the day, there were, I believe, 72 fatalities, which were all due to smoke inhalation, in this particular building. So, as a result of this building and this particular fire, the UK has banned the use of combustible foam plastic on high-rise buildings, as well as the use of combustible claddings, right? And so, now we're starting to see a movement in Northern Europe to use only non-combustible materials to achieve the requirements. And even here in New York City, the FDNY has started to pursue some more stringent guidelines around the use of foam plastics on high-rise buildings. So it's in the process of review as we speak, but I think there'll be some information coming forward fairly shortly. In general, in commercial construction, we oftentimes reference an assembly test called NFPA 285. Many of you might already be familiar with this, but this is not a product test. It is an assembly test that is used for allowing combustible materials to be used on building types that require non-combustible construction. So this was developed a number of decades ago, really through the foam plastics industry, to permit the use of foam plastics by testing it effectively on multi-story burn tests. So originally, a lot of it was done around masonry walls, but has transitioned, for use on Rainscreen walls and other types of assemblies as well. But what's important to recognize here again is it's a system test. So it will be triggered if you are specifying a foam plastic on the outside of a building, and then you would need to test with a specific cladding and use the proper joints and transitions. And a successful test will be needed to be used by code, but then that assembly needs to be built on sites identical to what was tested. So it's a little bit constrictive, and trying to intermix different materials can sometimes be complex from an engineering evaluation standpoint, but that's also commonly done. So again, it's triggered when you're using foam plastics from grade on most building types. If you move towards non-combustible insulation, like a stone wool insulation, that would not trigger the need for this test. However, if you are also specifying a combustible cladding, then the cladding itself would trigger it regardless. And so, oftentimes combustible cladding materials like HPL and ACM materials will often test with stone wool insulation to ensure that they're going to have a passing test. But the cladding trigger is at 40 feet and above by most code requirements, at least currently, whereas the foam plastic triggers right from grade. And this is what that test looks like. It's a multi-story burn test, as I mentioned. I spent a number of years with a manufacturer of HPL cladding in the technical side, so I have a lot of experience dealing with this. So I'm happy to answer questions at the end. But it's a complex test and quite expensive to execute. So we've seen a movement towards non-combustible insulation and non-combustible cladding to avoid those types of test assemblies. But it's referenced here in chapter 26 of the IBC. And it's not just NFPA 285 that needs to be considered. You also look at fire resistance rated walls, ASTM E119. You do have to use thermal barriers, and there's also flame spread and smoke development testing that's required with foam plastic insulation, which is not as critical with the non-combustible materials. And so I have another video. This is not the one I'm referencing now, but there's another video kind of comparing polyiso to stone wool. I thought this video was a little bit more relevant. This is from the UL Fire Service with all the forest fires that we've had in California and other areas of the country. There's been a renewed focus on wildlife-urban interface testing. And so this is comparing 2 walls, a vinyl siding wall over XPS insulation on the top here. And then you've got a similar vinyl siding over stone wool rigid insulation on the bottom. And so this was prompted because of the wildlife urban interface concerns, as I mentioned, in California in particular, where California is starting to increase the requirements for continuous insulation. But there's been concerns over how that could integrate with these fires and a concern over the use of foam plastic. So, what we're looking at here is, they started a fire at the base of each of these walls, and they're kind of measuring the time it takes for that fire to enter the attic space of this wood frame construction building. And so, we've had to push the stone wool clock fast, because after 30 minutes, they ended up having to shut this test down without the fire really moving past the vinyl siding. But you can see with the XPS wall above, I think in just under 3 minutes, it enters the attic space, and they have to diffuse it and kind of put the fire out. So there you'll see right at 3 minutes. So it's kind of an interesting visual on why, from a fire perspective, there has been this movement towards a non-combustible insulation, and I think we'll start to see some of these tests referenced moving forward in a lot of the codes. All right, so moving on from fire, long-term thermal resistance, right? So stone wool insulation is a fibrous insulation, and we also consider that a very stable R value. So there's trapped air in the fibers that help to make up the R value of the product, right? So a semi-rigid stone wool insulation that's used on the outside of buildings is roughly an R 4.3 per inch, which it'll be today, and it'll also be 80 or 90 years from now, right? So there's no blowing agents, there's no off-gassing that's going to create any sort of modification in that. And so now when you start to compare that to some of the foam insulation products on the market, in particular polyisocyanurate or XPS, which do use the blowing agents, as I mentioned before, they will off-gas over time, which is not great for a variety of reasons, but from a thermal perspective, you'll see a drop in nominal R value with polyisocyanurate. You'll see a drop of up to 20%. Sometime between year 2 and 20, and with extruded polystyrene, it's about a 10% drop, which doesn't drop them to awful levels by any means, but it might not be what you're expecting from the specification side. And as we're looking at making sure that these buildings are performing to our expectations, for more than 2 years, we want to make sure that we understand what the long-term performance values are of these products. And it shouldn't be a surprise. It's in the warranty terms for a lot of the manufacturers of the rigid boards, but it's just something to be aware of when you're looking to specify products. Additionally, temperature dependent R values. So if you're not aware, nominal or published R values for any sort of insulation product are all taken at a very static 75 degrees Fahrenheit in a hot box test. So those nominal R values tell you very little about how a product is actually performing at different temperatures. And so here's a chart, a graph of a variety of different insulations, commercial insulations that are on the market. And the bullet points here in the middle are just showing their nominal R values, or what you would see on their packaging as it relates to R value. And you'll see, as the temperatures increase in terms of the operational temperatures of those products, the R values will actually drop. But then when the temperatures decrease, when it starts to get cold out, the R values have a tendency to increase, which is helpful, because I think we're probably more concerned about R value when it's freezing outside or sub-freezing. And so, for instance, if you were to look at a stone wool batt insulation, which at about 75 degrees Fahrenheit is about a 4.3, 4.2 per inch, if you were to examine that same product when it's 0 degrees out, you're at about a 5.1 per inch, right? So there's certainly a difference there in performance. And that's the same for a lot of the products that are noted here. The one outlier is the polyisocyanurate, which you'll see here at about 55 degrees Fahrenheit starts to decrease down to about 4.3, 4.4 R per inch at 0 degrees. And so what's interesting here is in Canada, they're starting to require in the codes that manufacturers publish their R values at various temperatures so that we can all be aware of how these products are performing. That has not happened yet in US code, but I wouldn't be surprised if that's something that folks are looking at in the future. And just to kind of look at the outlier, the polyisocyanurate, there was a consulting firm RDH, Building Science Labs, Dr. John Straub and his team wanted to do some research on the polyiso, kind of this phenomenon of reduced R value. And what they noticed were that there was a series of products from manufacturers back in the mid-90s that would increase in R value at lower temperatures, but that trend stopped shortly thereafter, and now we're starting to see this drop. And so they were able to align it with the Montreal Protocol, and recognizing that there was a lot of blowing agents that were being banned for use in construction and other applications because of their impact on depleting the ozone layer. So as a result, they had to change their cocktail a bit And the gases that they're using now have a tendency to condense at roughly 50 degrees Fahrenheit and become more conductive. And so that's why you're starting to see a drop in that R value at lower temperatures. And so what does that mean, right? So if you're considering, combination or considering options of stone wool versus ISO, let's say on the exterior wall for continuous insulation, you might be looking at an ISO board that's 5.7 nominal R per inch when published versus a stone wool insulation that's 4.3 R per inch, again, nominal R value at 75 degrees Fahrenheit. However, when we drop to 25 degrees Fahrenheit, the stone wool insulation is actually outperforming the polyisocyanurate insulation, when those temperatures start to drop. So it's a dynamic scenario that I think we just all need to be aware of, is that R values are not static, and there's things that can impact them. Another item around stone wool insulation is just kind of in-field performance and flexibility. So when we call a product semi-rigid, that's usually in the 6 pound per cubic foot range of stone wool. And there's enough flex on that, even though it's a little rigid, there's enough flex that you can conform to radial applications, curved surfaces, and stone wool can do that quite well without leaving any sort of gaps for convective looping behind the insulation. So we oftentimes see in these unique buildings where architects want a little bit more design freedom, but also need to meet the requirements of continuous insulation, stone wool tends to be a good option here versus some of the more rigid products on the market. All right, so now moving on to dimensional stability. Like all materials, stone wool is going to have some level of expansion and contraction due to thermal shifts, right? So this is no different from other structural materials like concrete, steel, or rigid insulations. But I think what's important to note here is that stone wool moves very, very little, right? So it's got, the foam plastics are moving 12 to 20 times more in terms of expansion and contraction versus stone wool. And, what does that mean? So looking at this chart here, which is really focused more on roofing products, right? And we'll get into stone wool roofing materials in a minute. But on a 30-foot long board used in a low slope roofing application, if you were to see 122 degree Fahrenheit difference on that board, which is commonly seen on flat roofs, you would see 0.1 inches of movement along that 30-foot board or 33-foot board. If you compare that to extruded polystyrene, you would have about 1.6 inches of movement across 30 feet. And for polyisocyanurate, it's about 2.4 inches of movement. And so, what's the big deal about that expansion and contraction? And so normally I ask the audience what we see here. I'm gonna let you know what we see here in case you haven't guessed it, but this is convective heat loss, right? So this is a building in the Northeast that has a polyisocyanurate roof. And during the cold winter months, the board starts to contract and create these gaps between the boards. And so the heated interior environment starts to leak through those gaps and starts to melt the snow on the roof. You can also see some mechanical pins that are creating some thermal point bridges here as well. And so this means a couple of things, right? So this means that you're losing effective R value of the assembly by allowing that convective heat to come through. But you're also creating a lot of wear and tear on the roofing membrane here due to that expansion and contraction. So the more we can kind of protect that and maintain a stable R value, the better off we're going to be. And so stone wool helps to promote that. Moving on, water repellencies, right? So just to kind of demystify, a lot of people are concerned. They think of mineral wool as kind of a wool sweater. If you get it wet, it's ruinous and you've lost your R value. But with the semi-rigid and the rigid products, I just wanted to share this slide from a trade show that we did in pre-COVID times, where we actually integrated a koi farm right into the semi-rigid product to kind of showcase its water repellency and its hydrophobic nature. So, stone wool is hydrophobic, particularly the products that we're using on the exterior of buildings. So we're looking at moisture absorption under 1%. It can create a very effective drainage plan. So normally when I'm presenting this live, I try to pour some water on samples so you can see it bead, but this is visually what it would look like. And you'll often see rigid boards used, again, for foundation, walls, or under slab because of its ability to deflect and defer water. And so, one thing that I do want to note is that because trapped air makes up the R value within the insulation, if you were to put this product under a constant head of water, right, under a hydrostatic head of water, it will eventually take on water. The water goes through the gaps in the fibers, so it's not absorbed into the fibers. But what's beneficial here is how quickly the water can drain through, right? So, if you're to saturate a board for 30 minutes, within 12 hours, it's completely void of water. And so it's important to note, again, for, as you're comparing this to other insulations, like even fiberglass, like a stone wool bat insulation could get wet on a job site, and you let it dry out, and its R value is retained, its structure is retained, and you can still use the product. So again, it has some really good water quality components even for the bat insulation. All right, so moving on to vapor permeance. Right, so it's important to note that stone wool is not a vapor barrier. It's not going to trap vapor. It's a roughly 30 perms in terms of promoting drying capacity within walls. That'll vary a little bit based on the thickness of the materials you're specifying, but it really does help to maximize that drying potential. And as we should know, right, a good wall design, particularly in the Northeast, should not incorporate two true vapor barriers. We typically want to see if we're going to have a vapor barrier, like a membrane product, it should be located on the warm side of the wall. And so here in the Northeast, where we heat our buildings more than we cool them, at least for now, that vapor barrier should be on the inside of the wall. And so what that means is if you're doing split wall construction like we see here with some bat insulation in the studs, you've got a true vapor barrier to the inside of that. Now we have to think, well, if we put a water resistive barrier on the outside of this assembly, that should be vapor open, right? So it could be watertight and airtight, but vapor permeable. And so there's a lot of products on the market right now that meet that requirement. But the value of that vapor permeable water resistive barrier is going to be a function of the vapor permeance of the insulation, right? So we can't forget that the insulation comes into play here with diffusion and drying. So, additionally, stone wool is not going to support mold or fungus. It's a completely inorganic material, and it's really good for mixed climates. So this is what we want to avoid, where, if in the Northeast, we're trying to deal with that cold climate and allow heat flow through our walls. If we specify an XPS or polyisocyanurate for better R value, let's say, considerations, we might be overlooking the fact that it's vapor impermeable and compromising drying capacity of our walls. So again, we want to look at using interior vapor control layer, having maybe a vapor open stone wool bat insulation or fiberglass insulation. You've got your sheathing, a vapor permeable air barrier, a semi-rigid stone wool insulation, exterior continuous insulation, and then you've got your cladding. And this is kind of an ideal way to design for vapor permeance and drying. And just to kind of identify this in the passive house realm, right? So passive house buildings are being built extremely airtight. They're adding lots of thermal insulation. And so historically, we built buildings not very thermally efficient and not very airtight. And so buildings would get wet in the driving rain, and we would put a fire on the inside, and we would rapidly dry out the components in our walls because of all that air leakage and lack of insulation. So, as we're building more thermally efficient and more airtight, we can't rely on that heat flow as much to dry things out. So allowing for that diffusion is really, really critical as we build these high performance walls. So this becomes even more critical when you're looking at passive house type buildings. All right, so I'm going to move on to sound absorbency. I will be the first to admit that I'm not an expert on sound, but I'm going to try to play one right here. But we've got a lot of good folks behind us to help support this. But in general, sound is measured in decibels, right? And so looking at this chart here on the left, right, the noise decibels from a quiet room can be rated at about 25 versus a crying baby at 75, or a train at 100 meters, which you're looking at about 90 decibels. And so this sound travels in different ways. It can travel as incidental sound, radiated sound, reflected sound, structure-borne sound through materials. So, acoustics is complex. There's no single product that manages it all. It's oftentimes a system that needs to be considered. And the ratings that you're typically referencing are, is the STC ratings, right? So the sound transmission class, which is tested in accordance with ASTM E413. And so the range of frequencies that are measured here through STC is roughly 125 to 4,000 hertz. And the STC rating is going to be a decibel reduction average across that spectrum of frequency. So just because a product has a high STC rating doesn't necessarily mean it's going to be the best product for the application, because ultimately you should be looking at what sort of frequencies within the STC rating are you concerned with, because certain products might be better at lower frequencies or better than at higher frequencies. So not to create complexity, but if you're very focused on acoustics, sometimes it takes a deeper dive. And then there's OITC, which you may or may not be familiar with, but this is the outdoor-indoor transmission class. So STC, you could look at it for exterior walls, but oftentimes OITC is more referenced. And so the difference here is OITC is going to calculate the average over frequencies in the range of 80 to 4,000 hertz. So it gets to lower hertz frequencies within the rating. So it's taken into account airplane sounds, trains, anything that's at a lower frequency becomes part of the OITC ratings. And so that's why you would see a difference there. And I know that depending on how you're specifying and what sort of projects you're on, right, like LEED, B, D, and C, your healthcare is now starting to reference requirements around STC and OITC, and no surprise, schools are as well, right? So, controlling sound is a big challenge and something that needs to be addressed for our learning environment. So, that's where we're starting to see them referenced the most, and certainly around, large infrastructure projects, particularly in airports, you oftentimes see OITC ratings and a movement towards higher ratings and reduced decibel noise in these types of arenas. And so we often see stone wool specified in areas that require high OITC or STC ratings. And really it's a function of the flexibility in production. I mentioned before that there is trapped air within the fibers of the insulation. And so, because stone wool can be produced at different densities, it can create different levels of airflow resistance to meet the requirements of specific reduction of frequencies. At lower frequencies, you can have specific products that address that, or you can have specific products manufactured to address higher frequency sounds. You can also add surface protection, right? Membranes or things to the surface of the product that helped to control the sound in that way. As I mentioned, the density helps, but also importantly is the fiber diameter and fiber orientation. So you can kind of control within the production to have cross fibers or line fibers, depending on what you're looking to do. And so, as you have denser products, you have higher airflow resistance, which can be better in terms of managing sound reduction versus sound absorption. And like I said, right, so, this is a chart on the left kind of showing different densities of stone wool fibers. And you can see here by changing the density, you can address certain frequencies differently. And so, it's also important to look at that. And usually from the most part, there is a point of diminishing returns on thickness, but as you make thicker insulation, it does tend to help, but there is an end point there. I forget now what the thickness is, but we can look at that if there's questions. And so what does this all mean, right? So, here's typical STC levels of exterior walls. And so if you look at a commercial wall that has exterior foam insulation only, that might have a rating of STC 41. If you compare that to just having stone wool insulation on the outside, it's a bit higher at STC 44. If you have a combined batt insulation and semi-rigid stone wool on the outside of your wall, you can get to an STC 50. And so that difference, let's say between STC 50 and roughly an STC of 41 with foam is close to a 10 decibel difference. And so that basically equates to reducing audible noise 50%. So 10 might not seem like a lot, but it does really reduce the amount of sound that's coming through an assembly. So every STC value does count. And so it's something that we are seeing much more considered of late. And when it comes to using batt insulation, for acoustics purposes, stone wool tends to be a more dense product than fiberglass. So it naturally has a bit of an improvement with regards to STC. It's going to fit better as a friction fit between studs. And, there's no slumping or clumping that you'll sometimes see with a glass fiber insulation. So it does kind of help to contribute with a better fit. All right, so moving on to sustainability, which I think is a hot topic, certainly for this audience. With regards to stone wool, it is a natural renewable resource. There is recycled content up to 40% that comes from the slag-based materials. The stone is a very abundant natural resource, so it's not something that's scarce. So that has a relatively decent statement. I mean, compared to some of the foam plastics, right? So there's no off gassing into the environment with stone wool. There's no promotion of growth of mold or mildew. And certainly, if you guys are looking for LEED documentation, we have that, or stone wool manufacturers have that available as it relates to indoor environmental quality, air quality, materials and resource, and energy and atmosphere. So those are the key kind of categories that can be addressed with stone wool. And then EPDs, there are EPDs available through the North American Insulation Manufacturers Association. So NAMA has just generic EPDs as well, but certain product manufacturers might have their own EPDs that kind of get into the specifics and might dive into cradle to cradle type applications and getting a little bit deeper into embodied carbon. And so, carbon emissions is a big deal. For typical buildings, operational carbon is huge, and there's still embodied carbon that we do need to recognize. And as we get to high performance building, everything decreases, but the impact of embodied carbon becomes much more relevant, right? So when we're looking at meeting carbon emission goals by reducing energy use in our buildings, we can't forget that with the materials we're specifying, we also have to ensure that those products are not using up a tremendous amount of carbon to do their job. And so here's from the I think it's Architecture 2030 chart of kind of comparing and contrasting different commercial installations, or it's not specific commercial installations, but installations on the market, and kind of how they impact with their embodied carbon. So, there's a host of products from the rigid foams and the spray foams up top. Mineral wool and fiberglass tend to be at the middle of the chart here, and then you'll get into wool, dense packed cellulose, and some of the more hempcrete straw bale products at the bottom, which are carbon positive, carbon negative here. So, mineral wool tends to be right in the middle. So as you're looking at commercial insulation, you have to take into account other things like fire performance, durability. It tends to be a good choice for those types of commercial structures compared to some of the foam plastics. But I do want to mention that, not all mineral wools are the same, right? We've talked about stone wool versus slag wool. And so slag wool tends to be considered the recycled content of a material, of a mineral material, which many people look as a positive, which I would agree. It's good to have recycled content, but having more recycled content doesn't necessarily mean you're going to have a better carbon emission standpoint, right? So these are just kind of comparisons of manufacturers that might have less recycled content, but then also have a lower global warming potential than some of the products that have higher recycled content in that mineral wool realm. So you do want to look manufacturer to manufacturer as it relates to carbon emissions, but you also want to look beyond just carbon emissions, right? I think we all need to be thinking in that capacity, but we also need to select and specify products based on the intended application and the desired performance outside of that. So overall health and safety of building occupants is a primary concern. So when we talk about fire and durability, that needs to come into the question as well. And then just because a product might have a better statement around global warming potential, it doesn't necessarily mean that it's going to have a better impact with ozone depletion and smog potential. So we can't get stuck on just one element. We have to look at the bigger picture of the application and the other environmental impacts that materials might have in the environment. All right, so I'm going to kind of go through just a couple of applications with stone wool that I think are relevant to commercial passive house. The first is just going to be exterior walls. And so, you can certainly look at addressing and meeting code requirements on split wall insulation with stone wool bats, as well as semi-rigid stone wool products for the outside of a wall, right? So here we're looking at climate zone 4, trying to meet R13 and R7.5. Per ASHRAE 90.1. And so, we could again do that with stone wool. You would typically need to see on the bat insulation 3.5 inches of stone wool, so to get to an R15, and then 2 inches of stone wool to get to an R8.4, which would exceed that 7.5 requirement. So it's important to note is that that'll get you a nominal 25.15 R value, but the effective R value is going to be about an R18. Right, so we can't forget that when you're stuffing bat insulation between metal studs, that's going to derate your overall assembly, right? You've got some thermal bridges there that need to account for. But in general, with a single layer of batt and a single layer of board, you could get up to, it says here, R50 nominal. We've seen much more than that. In fact, now we offer 8 inches of semi-rigid board, 8 inches of batt, so we're getting up to the R60 plus. But from passive house perspective, where you double up boards, we've seen much higher. And so again, this helps from the vapor permeance standpoint and the acoustics and the fire standpoint, right? So you're getting a long-term stable R value, you're getting vapor permeance, you're getting fire resistance, moisture resistance, excellent sound absorption, and you know, relatively speaking, an environmentally sustainable outcome. What we can't forget when you're applying the semi-rigid or the rigid products to the outside of the wall is that we can't have too many thermal bridges to help support our cladding, right? So in this case, we're looking at a Rainscreen that's using a horizontal Z-girt continuously through the insulation on the outside of the wall. And so this linear thermal bridge, in this case, at 2 feet on center, is dramatically decreasing the overall effective R value, right? So now we're down to, you know, maybe 30% of what it could be. So we want to see a movement towards more thermally broken systems, less material bridging through the insulation, right? So this is a system from a manufacturer called Envelope, where they have clips and rails. And so if you're just having the clips, penetrate the insulation, you're starting to see a much higher performing type assembly. In this case, up to 75%, although they now have clips that can span slab to slab, and they're getting up into the 90–95% effective range. So you definitely want to think about those solutions, as well as fiberglass solutions, right? There's manufacturers out there that manufacture fiberglass clips like this. This was a passive house in Hoboken through Nastasia Architects, where they used 8 inches of semi-rigid stone wool in between the thermally broken clips. So pretty high level of R value there. And then there are pull-treated fiberglass components as well. So these are more like Z-girts made out of fiberglass. And again, fiberglass is a lot less conductive. And so that was used here at LaGuardia Airport's Terminal B, where they had 5.5 inches of stone wool through these thermally broken girts to get to some pretty high levels of performance. And lastly, there's also high density stone wool insulation. So as opposed to the semi-rigid products, there's rigid boards that are about 11 pounds per cubic foot. And those are rigid enough that you can actually screw through them. So you don't need Z-girts, you don't need clips. The only thing penetrating the insulation in this condition would be the fasteners for the cladding extrusions. And so now we're looking at much higher performance levels. This is a passive house in Corona, Queens that was getting up to almost meeting the R17. It was about 95% effective with these 4 inches of rigid board. And then lastly, stone wool roofing applications. And so some of you might not be familiar with it, but there are even higher density products manufactured by stone wool manufacturers that are in the 15 pound per cubic foot range that are used on low slope roofs. So they're rigid monolithic. They are dual density. So they are able to provide higher compressive strength by having that dual density, kind of a snowshoe effect on the roof itself. But it helps to eliminate the need for coverboards, which is really great. And you can have various sorts of roofing membranes depending on the products you're looking at. So the nominal R value is a little bit less than what you would see certainly with some of the other rigid foams. But as we mentioned, that nominal R value can be deceptive. So trying to consider stone wool as a roofing solution is starting to pop up more and more, right? So it can be used for new roofs, re-roof applications, torch and mop, single ply, a variety of deck types. And you can also have tapered systems, which we can see here, right? So it's really easy to cut and manufacture these. These are done just after production to get to the tapers that you need for your projects. And you can create thermally broken cant strips. So lots of interesting opportunities there. And so similar to the walls, right? The value here is the dimensional stability, the long-term R value, the fire resistance, impact, water, and sound. And so, we oftentimes see these products specified in industrial applications where fire is paramount of having a non-combustible roof. We also see it specified around airports where sound is the primary focus. But I think we do recognize that, at 3.8 R per inch, we're hard to compete with polyiso. And so, the marriage of stone wool and ISO can work, right? These are hybrid solutions that we're commonly seen specified, where the ISO might lose its R value at lower temperatures, or expand and contract due to temperature shifts, if you're able to actually insulate the polyisocyanurate, you keep it at a temperature where it can really maximize its nominal R value. So by putting a coverboard or a top layer of stone wool insulation that's dimensionally stable, you're then able to really maximize the overall performance of the wall. And so these types of assemblies are warranted through a variety of membrane manufacturers. So they're out there as opportunities. We've seen it in New York City. This is on the Empire State Building, where they use this hybrid solution from a sustainability perspective as well as a fire perspective, was the two driving factors there.
I saw some regarding availability of the product.
Okay.
Can I buy it at Home Depot? Can I buy it at Lowe's? Or how do I get that stuff?
Yeah, so just to answer that one, so yes, so depending on, if it's a residential application, we are available at the box stores. We have commonly our comfort bat, our bat insulation, as well as our rigid boards, our Coverboard 80. If it's not in stock there, you would be able to ask the help desk at the box stores to get those products. From a commercial availability standpoint, we're pretty ubiquitous at the major commercial distributors of insulation and membranes within the city. So I'm happy to send you a list of who has our products available. They might not always be in stock, but some of the more common products like Cavity Rock, Comfort Bat, and AFB are pretty readily available.
Todd, are you familiar with a comparison? 475 has a video comparing EPS and Rockwool and Gutex.
I'm not offhand familiar with it. Is it comparing it by R value or embodied carbon or?
A performance measured temperature field test.
Okay.
I don't know if it's comparable R values or just comparable thicknesses.
Yeah, I'd have to take a look, unfortunately, but I'm happy to look at that after the program and respond to the inquiring party.
Yeah, links in the chat.
Okay, perfect.
I know you touched on it a little bit about circularity and recycling. There were some questions around embodied carbon and recycling. I know we covered this in a similar question yesterday.
Yeah, so we have the information through the EPD, and we can provide some information on the embodied carbon that we showed. With regards to recycling, right? So the slag, the byproduct from the iron ore and the steel production does make up the recycled content within the material. As far as recyclability of the insulation itself, we do have programs set up globally to take product back to manufacturing facilities and to throw it back on the hopper, and that can be done easy peasy per se. The challenge in North America is that we're fairly spread out, and so while we have 5 production facilities, if we're trying to send material from New York to Toronto, or you start to kind of lose the value in the transportation of those products to those manufacturing facilities. So we don't have that program set up yet domestically, but I think as we grow and we see a demand for it, that's certainly been part of the conversation that I've been involved with within Rockwool in my 3 years here. So they are looking at that for sure.
So there's a question by Jim. He asks if Rockwool recommends installing the product on the exterior in 1 layer or in 2 layers.
Well, it depends. I would say that if you're able to do it with 1 layer, that's great. I think stone wool is a little bit more heavy than a foam plastic. So as you get to thicker layers, you just want to kind of assess what your project typology is and what sort of labor force you've got. Doing it in thinner layers can be a little bit more easy as a one-man job to get it up on the wall. So it just depends. Our semi-rigid products, we do see manufactured up to 8 inches in a single go, and that's done fairly regularly if you're looking at high performance of that level. For our rigid products, usually we produce up to about 3 inches because as you get to 11 pounds or 15 pounds per cubic foot, it starts to get quite heavy. So it's just a kind of give and take on what you're trying to achieve. But we've seen 4 layers put up in the past on some passive house buildings, 10 or 12 inches on rigid board screw through insulation. So it is done quite commonly with doubling up.
There was also a question about below grade applications.
Yeah, so I don't see the specific question, but let me see. In general, you would look at our rigid products. So a product called Coverboard 80 is commonly used for under slab as well as foundation walls. So that is, and we have some good details on that. I don't have it up right now, but I'd be happy to send you some information there. But it does have full ICC acceptance criteria testing for the use in below grade applications. And so that is commonly done globally. We're seeing more and more of it now in the US. But again, it's got really good hydrophobic and drainage qualities. So putting it up against foundation walls, you wouldn't want to put it under the water table. And similar, like if you're doing a low slope roof, you wouldn't use this as an Irma roof product. You'd always have the membrane on top. But those are applications that are completely adequate for stone wool rigid products. Just quickly, so Rockwell has gone ahead and executed certified passive house details through PHI. So we have some really good literature and brochures around that as far as guidance to meet the passive house requirements with stone wool insulation. In general, we commonly see a product called Cavity Rock, which is our semi-rigid R4.3 per inch used on the outside of buildings. And we also have now, for those people who may or may not be aware of it, a black-faced Cavity Rock. This is a picture from my kitchen, just so you know, but there's been a demand, particularly for open joint cladding or perforated cladding, to not see the stone wool through the joints or through the perforations. And so this is a very hot off the presses product that we're already seeing spike up in demand. That again, it has a polypropylene facer that doesn't diminutize the non-combustibility characteristics of the product. It's not meant to be a water resistive barrier. It's just meant to be as a pure aesthetic that's also vapor open. So it's not compromising the drying capacity of the walls. So if you guys are working on open joint cladding, Rainscreen cladding assemblies, definitely consider that product. So the Cavity Rock was used on the Cornell Tech building here in the city that you guys might be familiar with, which was one of the largest passive house buildings at its time. I think we've now exceeded that. Stone wool and Cavity Rock was considered as part of the specification for DH Architects 211 West 29th Street. So you can see kind of a detail of what that enclosure looked like with fiber cement panels. This is another recent high-rise passive house in New York City, 511 East 86th Street, where they used porcelain panels, the porcelanosa tiles outside in a Rainscreen application over a few inches of Cavity Rock here. I referenced this project before. This is in Hoboken. This is the Candela Lofts project through Nastasi Architects that used Cascadia clip and 8 inches of Cavity Rock. This was doubled up, right? So this was 2 layers of 4-inch Cavity Rock that were used here, and friction fit between the clips. And then some upcoming projects where stone wool is the basis of design or involved certainly in the specifications. This is the 425 Grand Concourse project with Datner Architects. They've broken ground. I'm not sure where things currently sit on the Sindaro Verde project, which is going to be, I think, the largest by volume passive house in the world, like an entire city block, for those of you who aren't familiar with it. Stone wool is also being considered for the Winthrop Center up in Boston, which will be the largest passive house in the city of Boston moving forward. And then beyond the Cavity Rock product, I mentioned we have a rigid product for continuous insulation as well. So this is the Coverboard 110. Its sister product is the Coverboard 80, which is a little bit lower density. But either one of them can be used as continuous insulation. And so neither of these products request of strength to transfer the cladding load through the high density insulation back to the structure. By the ability to apply your cladding without thermal bridging, the effective R value of the assemblies are increased, right? And so we're seeing this. This was specified on the passive house up in Hanac, Corona, the Hanac Corona Senior Housing Facility in Queens. It's also being considered for specification on the Magnuson Architects project decal commons, which is on the books. So just quickly with Rockwell tools and support, right? So I mentioned we have Passive House certified details. You can visit our site for this information. We have a really great guide around that to give you a sense of how to approach that. And I think even more importantly, we have some really great building science services that are fully complementary. A lot of folks in New York are using this, so you may have already been aware of this, but we can run effective R-value calculations. We can kind of showcase the ability for your designs to meet the code requirements, the ever-changing code requirements in New York. So not, if you're going beyond prescriptive, we can certainly help here. We also have the ability to run dew point calculations and run WUFI modeling, as well as run 3D thermal imaging of thermal bridge modeling as well. So if you guys are working on projects where you really want to kind of hone in on these details, don't hesitate to reach out. Again, it's a fully complementary service. You don't have to use Rockwell products either. We just recognize that insulation is more than just a nominal R value. There's a lot of things that you guys need to consider. So we're happy to offer these services to you, and we're pretty quick with turnaround on that. And then lastly, we have some really great guides. So I encourage you guys to visit our website and poke around. But a lot of good information from mid-rise wood solutions guide to a cladding attachment solutions guide, all around trying to maximize effective R value and address some of the building science challenges that you guys are facing every day. All right, so that's a lot of talking on my end, but I do appreciate everyone's attending today. I hope everyone is well. Here's my contact information, and yeah, thank you for being a member of New York Passive House and supporting New York Passive House. Andres and the group are doing a lot of great things these days, and it's good to have you guys involved.
So yeah, thank you everyone for joining. That was a very interesting presentation, like always. Todd is a true expert. And you showed all the good stuff at the end, but it's okay. It all came, the good projects here in New York. So thanks for the presentation, Todd, and thanks for Rockwell to make that possible. And we will send out the recording and the follow-up with everyone probably over the next few days.
Great.
Thanks, guys.
All right. Thank you, everyone.